Okay, so the last subject under the sun in chapter 4 has to deal with what we call differential equations. And a differential equation, all it really is an equation with a derivative in it. Let's write that down. A differential equation is simply, it's defined to be as simply an equation with a derivative in it. But I'll have to say now, I'm going to be, I'll just say the following. I'll put this in red. To solve a differential equation really means to find the original function. So in other words, they're going to give us a derivative equation or a second derivative equation, and we're supposed to bump up and find the original function. So in this, I'm going to give you two examples. One is just straight up, let's mess with a differential equation. The second one's going to deal with motion, like position, velocity, acceleration. It's really good stuff. Okay, so in this problem, as an example, they say, what is f double prime? Here is f double prime is equal to 4x cubed minus 2x plus 3. The instructions in this section say something like find f, basically. So he goes find f, or f of x, a definition for f. Well, here's a little memory thing. Remember, antiderivatives is really going the opposite direction. So if someone said, oh, gee, f of x is 3x squared plus 2x, and they go, find the second derivative, you'd go, well, what I would do is I would derive, and I would find f prime of x is equal to, what, 6x plus 2? And then I want the second derivative. Okay, so what do? I derive again. Remember this? To find f double prime of x is just 6, right? So if you derive in one direction, what do you do to come back up to the original function here? That's right. You're going to anti-derive, right? And anti-derive here. Of course, when you anti-derive, you have to say, well, there might be a constant of integration. So if I lift up from 6 to go to 6x, I'm going to put a plus c here, and then maybe later know that it's 2. Okay. So let's do the same thing. They're asking us to find f, but they gave us f double prime. So what are we going to do? We're going to anti-derive. So when we do that, and if we've been practicing, we will call it f prime is the antiderivative of f double prime. F double prime is the derivative of f prime, and vice versa, right? So we'll go, it's equal to 4 times, remember the rule for powers? X to the 3 plus 1 is 4 over 4, minus 2 times x to the 1 plus 1 is 2 over 2, plus 3 times, well, if it's a constant and you're anti-deriving, you tack on an x, and then you go plus c. So cleaning up, we have a general form of the first derivative of this function, given what they gave us about the second derivative. And it looks like this, okay? But they want the second derivative. I mean, they want the original function. We are at the first derivative level, right? We're going down, going down. Okay, now we're going up and going up. We're going in this direction, right? So we are going to, guess what? Anti-derive again. Pretty straightforward. And so we would say, instead of f prime, we're going to say, now I'm going up to the original function level. You ready to do that? We go like this. We go, okay, so this is now x to the 4 plus 1 is 5 over 5 minus x to the 2 plus 1 is 3 over 3 plus 3 times x to the 1 plus 1 is 2 over 2. This is weird, watch. Plus That's a constant. What do we do when we derive a constant? We tack on an x, and then maybe constant of integration is another constant k. Weird looking. That's really general though, and this is what we've got. We've got, say, 1/5 x to the 5th minus 1/3 x to the 3rd plus 3/2 x squared plus some constant times x plus another constant. Very good. So in a way, this guy is done. Okay? All right. So what now? The other thing to learn is that I scribbled them out up here because I didn't write them right. But let's say they gave us, say, an initial condition, and I'll keep it easy, but it could be something else. So for example, they might say, oh, and by the way, I'm kind of picky. I thank you for finding f, but I want it such that f of, say, 0 is equal to 5. But also I want it so that f prime of 0, say, is -2. And you're going, oh, great. F prime of 0 is -2. Let's bring f prime back. In fact, I could, if I knew that at the beginning, I would have done this before finding the original function. So I bring f prime back, right, which I'll write out. But someone is saying, hey, if I plug in 0, I want -2. In other words, pretend I want the slope of the curve at that point where x is 0, negative. I want the slope to be -2. So, all right, I'll rewrite this and I'll go f prime of 0, okay, is equal to 0 to the 4th minus 0, what was it, cubed? I can't read my writing. Squared? Okay, and then plus 3 times 0 and plus c. And you know what I want that to be? I want it to be -2. So when I plug in 0, that's why zeros are easy, I get -2. And you know what that tells you what c is? C should be -2. Do you see that? So now I know that your function, your unique solution, we call it in other classes, which as opposed to, say, the general solution, which we also call in other classes and in this class, is found to be, you rewrite it, you just go the derivative of x4 minus x squared plus 3x, but now we know that that guy's -2. Oh, that looks more real. But then, okay, so we use that guy, but we have another one. They also want f of 0 to be 5, and you know what? You do the same thing. So now you take down f, which is this long string, so f of x is equal to 1/5 x to the 5th, etc., minus 1/3 x cubed plus 3/2 x squared plus, wait a minute, I know what c is now, right? So minus 2x plus k. You know what, you do the same thing. I'll save some ink. I'll just go f of 0, I'll put a 0 here, 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 and all of that we want to be equal to 5, okay? So when you do f of 0, it's going to be 1/5 0 to the 5th minus 1/3 0 cubed, etc. This is a 2, right? 3/2 squared minus 2 times that plus k. And if you plug in 0, it's pretty clear that k should be 5. And so now here is your unique solution. You write the whole thing out again. It's 1/5 x to the 5th minus 1/3 x cubed plus 3/2 x squared minus 2x plus 5. Now, if they tell you x is 0 and they give you these initial conditions, it's pretty easy to figure out what the constants are. But it could have been f of 1 equals and f prime of -2 equals. And they can be funny that way too. You just have to plug the number in, and it's a little messier, but you can find these constants. And this is the unique solution right there, this guy. All right, let's do one more example. This time it'll be motion. You can pause it and rewind it or whatever. This particular problem, I might have taken this. We're going for the position function, and you know what they get, which is s of t, and they've given us acceleration, and they've given us at 0 what the position is, and at 0 what the velocity is. This is identical to what we did, right? If you're given a s of t, and you want to find the velocity function or the acceleration function, this might be an old memory for you, but to do that, you derive, right? The velocity is the rate at which the position changes. The acceleration is the rate at which the velocity changes. So that's what the derivative tells you. But if we want to climb the ladder back up, this way, in each case you anti-derive. Okay? Same thing. So roll your sleeves up. We'll grab this acceleration function, which is found to be 3 cosine t minus 2 sine t. And the first thing we'll do is we're going to anti-derive. That'll take us up to the what? The velocity level. Okay, we're coming back up now. So we have to think, okay, 3 times the function whose derivative is cosine is sine, minus 2 times the function whose derivative is sine. Well, that's a problem, isn't it? The derivative of cosine is negative sine, isn't it? So if they say, what's the antiderivative of sine? Watch this. You ready? I'm going to take this negative and make it plus, and I'll put it out there. So when I derive negative cosine, I get minus a minus sine. Get it? So this guy turns out to be negative cosine. Watch out for that guy. And then plus c. So clean up. Here's your velocity function. It's 3 sine t plus 2 cosine t plus c. Now, here's the thing. Your velocity at 0 is 4. I'm going to use that right now. The velocity of 0 has to be 4. That's going to help us find c. So we'll say the velocity of 0 for us is 3 sine 0 plus 2 cosine 0 plus c, and we want it to be what? 4. Now you got to know your trig. Well, sine of 0 is 0, but cosine of 0 is 1. So we get 2 times 1 plus c is 4. So that tells us, guess what c is? It's 2. And so do yourself a favor and rewrite velocity. The velocity is now 3 sine plus 2 cosine, right? And then what else? Plus 2. Now you're ready to go to the next level. Let's go to the position function that they ask us to find. Okay, what do? We anti-derive again. All right, so let's do it. We're doing pretty good. All right, so the position function now is 3 times, okay, sine again, guess what? Negative cosine. Students stumble over that. You will too until you get it straightened out. Plus 2 times the function whose derivative is cosine is sine. Now we have a plus 2. What do we do with it? Tack on the variable t. And we have another constant of integration. Maybe call it k. You can call it c again if you want. Okay? So clean it up. S of t, pretty mechanical, right, is minus 3 cosine t plus 2 sine t plus 2t plus k. But what's the story with the initial condition up here? Where is it? Oh, S of 0 is 0. So you probably can tell me what the answer is, but I'm now going to use S of 0 is 0 to figure out what k is. So for us, S of 0 means minus 3 cosine of 0 plus 2 sine 0 plus 2 times 0. That's all of the t values are 0 plus k, and we want that to be 0. You'd think k is 0. You'll be in for a surprise, because what we have is minus 3 cosine of 0 is 1 again. Hello. Plus 0 plus 0 plus k is equal to 0. So what is k? Looks like k is 3 when you throw it to the other side. So let's write our final answer. And this is it. Our position function with all that information turns out to be, right up here, minus 3 cosine t plus 2 sine t what was plus 2t, and then now plus 3. There it is. That's how you do the differential equations. Okay, let's study that thing. It's pretty mechanical. We'll see you later.